Hello teachers, today I am going to give a demo lesson on 9th class physical sciences. First of all, I am requesting you to observe what are the steps I am following during the demo lesson and what are the strategies I am following in the demo lesson, because at the end of the lesson I will give you what are the steps I adopted during the lesson and the suggested strategies and steps. Just ask the students to make a list of sounds you hear in your surroundings. Now let us start the lesson. Just try to recognize this sound. Yes, exactly. This is the chirping of a bird. Now let us start to recognize the another sound. Yes, it is the clapping sound. Now let us recognize another sound. Yes, exactly. This is the beep sound of a car when it is going to start. Now let us try to identify another sound. Exactly, this is the ringing of a bell. Please ask the students to make a list of sounds you hear in your surroundings. They will make a list of sounds what they observe in their surroundings. Already we heard so many sounds regarding chirping of bird and also the car beep sound and also the bell ringing sound, clapping sound. So many sounds we heard and we recognized. Now you have to pose some questions to students that must ignite the production of sound. Some questions has to arise in the student's mind. First of all, make the students to think why it was happened, what was happened, how it was happened. Already we heard so many sounds and we recognized so many sounds. How sound can be produced? How we are able to hear the sound? How we are going to recognize that particular sound? Does sound requires a medium to travel? All these questions we have to pose to the students. Yes, now I am showing an activity. Here you can see a boy is having a cup with and a balloon was attached at the top of the bottle, and at the bottom of the bottle he cut that portion. Then on the top of the portion where he kept the balloon and it was tied with the rubber band, he poured some grains. Just he is speaking, at the bottom of the bottle the grains are moving. Why these grains are moving? Only he is speaking, no? Even though the grains are moving. Why the grains are moving? Because the sound has energy. That means today in our lesson we are going to learn about one form of energy, that is sound. Already in the previous classes we learnt about so many forms of energies: light energy, chemical energy, mechanical energy. Likewise we learned so many forms of energy and the conservation of energy. Energy can neither be created nor be destroyed, and it will transform from one form of energy into another form of energy. Today we are going to discuss about the sound. Let us start the sound lesson. First of all, we have to grab the words, terminologies and also the experiences, what they experienced. By the students, we have to take those experiences and we have to prepare a map like that. We have to brainstorm the keywords or the words regarding the sound. And this is the total concept map of the sound. Here we can see the sound waves, properties of sound, hearing and noise. Under sound waves, we are going to discuss about the production of sound waves, propagation of sound waves, type of sound waves. In this session, we are going to deal about the production of sound, propagation of sound, and sound requires a medium. Likewise, we have to discuss these sort of issues. Under this, we have to identify the keywords like sound, vibration, compression, rarefaction, longitudinal wave, mechanical wave, transverse wave, etc. First of all, underline these keywords in your textbook and please say loudly what are the keywords. Yes, sound is a keyword. Vibration, that is a keyword. Compression, yes, that is a keyword. Rarefaction, longitudinal wave, mechanical wave, transverse wave. Okay, let us start the lesson. In the textbook, the activity 11.1 for the production of sound, it is an activity is there. We want to know about how the sound is going to be produced. Already we heard so many sounds regarding the chirping of bird, bell ringing sound, so many sounds we heard. How the sounds are going to be produced, how we can produce the sound, this is the question in our mind now. So, to get the knowledge, first of all we shall do some sort of activities which are there in the textbook. Take a tuning fork and set it vibrating. By hitting the prongs, keep that tuning fork near your ear. Do you hear any sound? Then you touch the prongs of the vibrating tuning fork with your finger. What is your experience? Please note down your experience. And here you can see. Yes, you can hear this type of sound. If you touch the prongs of the tuning fork, you can feel that vibration of the tuning fork. And next we shall see another scenario. Please put that vibrating tuning fork near a bob of pendulum. Then what you can observe? Pendulum will be moved forward. Due to the vibrating tuning fork, that bob will be pushed forward. That means you can hear the voice of the tuning fork also, and also we can observe forward motion of the bob also. That means the vibrating body will push the surrounding particles. We understood that one. Okay. And one more activity 11.2 which is there in your textbook. Just please fill the water in a beaker or in a glass up to the trim and gently touch the water surface with the one of the prongs of the vibrating tuning fork. Here the vibrating tuning fork is there. Just I touched that tuning fork at the surface level of the water. That means the vibrating tuning fork is there. The surrounding particles in the medium, they will push forward. That means by the vibrating body, we can produce the sound. I am showing the upper portion. Now we shall see some more examples also. Just here I kept a pencil box. In the pencil box I kept two pencils and I kept a rubber band. Now I am stretching that rubber band. What you can observe? We can produce the sound. That means the vibrating body will produce the sound. And also in the second scenario, the boy is beating some steel vessel. Then we can observe the sound. In all the scenarios, we can observe the vibrating object as the to and fro motion of an object. So, the to and fro motion of an object is termed as vibration. So, sound is produced by a vibrating body. That is the thing we have to confine. If the vibrating body is there, we shall get the sound. The to and fro motion of a body is termed as the vibration. You can see here. And also some more examples. We shall take a plate, steel plate. If you hit the steel plate with the spoon, we can get the sound. And also some more example is there. In all the examples what we observe, the to and fro motion is termed as vibration, and the object vibrates and produces sound. Nice, very nice. I am speaking, no, I am speaking with you. How the sound is going to be produced? Because the sound is produced due to the vibration of the vocal cords. So, due to the vibrations of vocal cords only, the sound is going to be produced and you are hearing. Now we shall see some of the musical instruments. Because these musical instruments are simply beaten or struck to produce the sound. Here veena is there, some stretched string will be there. We can vibrate that stretched string, we can hear the voice of veena. You may observe. Because you may observe the difference between these sounds. Now I am putting, this is the tabla. Here the vibrating part is the membrane, whereas in the veena that is the stretched string, here the membrane will be vibrated. And also you can see here, yes, P. And also here one more, guitar. Likewise, we can have so many musical instruments. By vibrating different parts of that particular objects, we can get different types of sounds. Anyway, we can confirm that a vibrating body will produce a sound. The to and fro motion of a body is called a vibration. And now I am giving a project as an activity 11.3 in the textbook. Make a list of different types of musical instruments and discuss with your friends which part of the instrument vibrates to produce sound, because sound is produced. Yes, okay. But there are so many variations in the sound. We are going to recognize different types of sounds, no? Because this is the chirping of bird without seeing that also. Because based on that, which part of the instrument vibrates, that will differ. So, just take a tabular form, serial number, musical instrument and vibrating part producer sound, and please all the what else the musical instruments you are seeing in your day to day life, please post those in the musical instruments line, and then just observe the which part is going to be vibrate. Do this as a project work. Now we arrived the answers for the first question. What is the first question? How sound will be produced? Sound can be produced by plucking, scratching, rubbing, blowing, somewhat shaking. Likewise, we are doing so many things to vibrate a body, because the vibrating body will produce the sound. Okay, this is the question, how sound can be produced. Now we came to confine that vibrating body will produce the sound. Now we shall go to the another question. How you are able to hear the sound? Yes, the sound is producing, the vibrating body that will produce the sound. Even though it is producing the sound, you are hearing the sound. No, how you are hearing? Because from the source of sound, it has to reach your ear or destination, no? How it is happening. Now we shall know about that one. Here you can see some disturbance. We are throwing a stone and we are seeing some sort of disturbance. The disturbance is going on, and it is actually the particles surrounding the disturbance, they are pushing the adjacent particles forward. And again the particles, the pushed particles will push the adjacent particles. Likewise, the disturbance is propagating like this. This FET Colorado simulations also, I am going to show those also. Just I am clicking the FET simulations. First of all, this is a very useful links you have mapped with the simulations. Now I am using the FET interactive simulations to teach sound, because you have the AFP panels. Here you can see. Just I am clicking this one. See how the disturbance is propagating from one point to another point due to the vibrating body. Now I am showing the particles also. Here you can observe the particles do not travel all the way from the vibrating object to the ear. But what it is happening? A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position, and it in turn exerts a force on the adjacent particle, as a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particles, the first particle comes back to its original position. That means the adjacent particle pushes the next adjacent particle, and this particle which pushed the adjacent particle will come into the rest, and it will attain its equilibrium position. You can see. That means the particles of the medium do not move forward themselves, just they will vibrate only, but the disturbance is carried forward. This is what happens during the propagation of sound in a medium, which can be visualized as a wave. So, sound wave we are calling that as a longitudinal wave also, and also mechanical wave also. Why we are calling sound wave as a mechanical wave and also as a longitudinal wave, we can see here. Here you can see the same scenario what we observed in the simulation. When an object vibrated, it sets the particles of the medium around it vibrating. That means the vibrated object, the particles surrounding the vibrated object will push forward, and those particles again will push forward the adjacent particles. That means the process will continue, but the particles which pushed the adjacent particles will come again to the rest their equilibrium position. That this process continues in the medium till the sound reaches your ear. That means the particles just they are vibrating and they are pushing the adjacent particles, but again they are coming to the equilibrium position. That means the position of the particles is not changing, but the disturbance and the sound is going to be carried. That means this process continues. This is the process of propagation of sound. Here you can see how the particle is pushing forward the adjacent particle, and the first particle is coming again to its original position, to its equilibrium position, it's the original position. See here, and also you have to observe two things here. The direction of energy transfer, that is the direction of sound, the direction of energy transfer, and also the direction of the particles, the movement of the particles. Here you can see the direction of energy transfer and also the direction of movement of particles are the same parallel. They are in the same direction, they are in the parallel direction. See here, once again you may observe the direction of energy transfer and the direction of movement of particles, they are in parallel, they are in the same direction. So, okay, when a vibrating object moves forward, already we observed the particles around the vibrating object, they will push the particles forward. The vibrating object will push the surrounding particles forward. When it pushes, and compress, because here we are seeing the example tuning fork. Tuning fork is vibrated because it is in the air, so that I am telling as the medium as air. Okay. In the air, when the vibrated tuning fork pushes the surrounding particles forward, when it pushes and compress the air in front of it, creating a region of high pressure. Whenever the air pushed forward, at that particular place a high pressure region will be created. This region is called a compression. And again, what we discussed earlier, the vibrating object moves backwards, to and fro, moves forward and backward. When the vibrating object moves backwards, it creates again a region of low pressure. Because it is moving, when it moves forward, it pushes and it will form a high pressure region called compression, and backwards it will create a region of low pressure called rarefaction. Continuously the vibrations to and fro motion, during the vibration process to and fro motion, the compression, rarefaction, compression, rarefaction. Alternatively, those compressions and rarefactions will be formed as a longitudinal wave. And also the distance between two compressions or rarefactions is also called as wavelength, that is lambda. Here you can see how the particles are moving. The particles of the medium vibrate parallel to the direction of the wave. Here we can observe the vibration of the movement of the particles of the medium and the propagation of wave also. See here again you can see the motion of the particles and also the direction of the motion of the particles and direction of the wave also. A sound wave is called a longitudinal wave. Already we discussed the sound wave is a longitudinal wave. Why the sound wave is a longitudinal wave? We are calling it as because it travels in the form of compressions and rarefactions in the medium, where the particles of the medium vibrate in a direction which is parallel to the direction of propagation of the sound wave. That is more important, we have to underline that word, where the particles of the medium vibrate in a direction which is parallel to the direction of the propagation of the sound wave. Okay. Now, why the sound wave is a longitudinal wave? We had given the explanation. And sound wave is also comprising of compressions and rarefactions, and the distance between two successive compressions or rarefactions is the wavelength. Okay. The distance between, here you can see the distance between two successive compressions or two successive rarefactions is called the wavelength. Okay. For the two questions already we got the information, how the sound will be produced and how the sound will propagate from source to destination. Now we shall have a doubt. And also one more thing we clarified, sound is a longitudinal wave. Does sound requires a medium to travel? We shall clarify, because the particles of the surrounding medium, it is moving, no? Now let us see. Sound produced by vibrating objects. Already we concluded that one. The matter or substance in which the sound is transmitted is called a medium. The matter or a substance through which the sound is transmitted is called a medium. It may be solid, liquid or gas. Already in the previous scenario, when the bell rang, vibrating tuning fork, we heard the sound. Because the sound is propagating, that particular sound that is propagating in the air. Therefore, we can conclude that in the gaseous state or in the air, sound can propagate. Because in that particular scenario, the medium is the gas or air. We can see another scenario. Sound can travel through wood. or any solid or any metal. Here you can see an example. Two boys are there. One boy is putting a steel scale and one boy is putting that steel scale on the ear. Just he is vibrating the steel scale just a little bit, and he can hear that vibration, the sound produced by that vibrating steel scale. That means here the sound is propagating to the in the steel scale, that is the sound is traveling in the steel scale, that is the medium is the steel. And also in the second scenario, just the boy is tapping the table, the other boy is putting his ear on the table and he is hearing that particular sound. He is vibrating. Due to that vibration, the sound will be produced, that sound is going to be heard by that particular boy. Here the medium is the wooden table. So we can conclude that sound can travel through solids. Here the medium is solid. Just do one very fascinating activity, that is paper cup telephone. No? Take two paper cups and with the help of a thread just prepare a paper cup telephone. Just you may speak with your friend like that. Here what it is happening, the sound is propagating through the thread, that is string, that thread is there, no, from source to destination. So please prepare this type of small toy and enjoy. Okay. And here you can see a boy, he kept a ringing bell in the water and he is putting his ear on the surface of the water and he is trying to listen that particular sound. Can he hear? Yes, exactly, he can hear. He is listening that particular sound. That means what we can conclude? The ringing bell sound the boy is hearing, that the particular, in this particular scenario, what is the medium? Water. That means sound is traveling through water. Here there is an application also, how whales and dolphins might be communicating underwater. So we can conclude that sound waves can travel solids, liquids and gases. That means there is a medium. If there is no medium, what will be happen? We can see here. Here I kept like that bell jar. In that bell jar I kept a electric bell and I kept a vacuum pump also. Whenever we ring that bell, we can hear the voice. Whenever or gradually we are evacuating that bell jar, gradually the loudness of the sound will decrease. Ultimately at the particular point of time, we can't hear that bell ringing sound even though it is ringing. Why we could not hear that particular sound? Because there is no medium, we evacuated that one. So we can conclude that for the propagation of the sound, it requires medium. Definitely there must be a medium. And also one more activity, just put some phone or any source of sound in your tumbler and just if you close that, you can feel the decreasing loudness of that particular sound. So we can conclude that sound needs a medium to travel. Sound cannot travel through vacuum. So the vibrating body produces sound, and also the propagation of sound we learnt. For the propagation of sound, there must be a medium also. So here one important word is there. Since the sound waves are characterized by the motion of particles in the medium, they are called mechanical waves. Already we told sound waves are longitudinal waves. Now we are telling that mechanical waves. Why? Because waves are characterized by the motion of particles in the medium. They are called mechanical waves. Okay. Now we can see here mechanical wave. Here above portion is the mechanical wave, medium is necessary. In the bottom part we can see the electromagnetic wave. A light is an electromagnetic wave, there is no need of medium, but whereas for sound that is a mechanical wave, medium, definitely medium should be there, then only we can receive the sound. Okay. Now you understood about the difference between the mechanical wave and the electromagnetic wave, so that we can hear the sound but we can't see the sound. Here mechanical wave and light wave you can observe very clearly here. Okay. Already we learnt about the sound waves, those are longitudinal waves, and some other type of waves are also there, those are transverse wave. In the longitudinal wave, what we discussed, the particles of the medium vibrate parallel to the direction of propagation of, whereas in the longitudinal waves already we learned that the particles of the medium vibrate parallel to the direction of the propagation of the wave. Here we can observe, whereas in the case of transverse wave, the particles of the medium vibrate perpendicular to the direction of the propagation of wave. See here the particles of the motion, the direction of the particle motion and the wave motion. Here whereas there we discussed the high density regions, high pressure regions as the compression and rarefaction, and low density regions as rarefactions. Here crust trough. Okay. The distance between two crusts or distance between two troughs is called the wavelength. Here this is an example for the, here you can see for the transverse waves. Here you can see the transfer wave motion, see here, yes, and also you can observe the motion of the particles also. Here you can see just the particles of the medium vibrate perpendicular to the direction of the wave. See here the direction of wave and the particle motion are perpendicular in direction. Okay. Here you can see here again, yes, the particles of the medium vibrate perpendicular to the direction of the wave here. So we can conclude that the distance between any compressions or rarefactions or any two successive compressions or any two successive rarefactions is called the wavelength, or in the case of transverse waves the distance between any two crusts or distance between any two troughs is called the wavelength. Okay, here you can see the crust troughs and also compressions and rarefactions. Okay, now we can compare the direction of motion of the wave and also the direction of the particle movement of the particles also, both in longitudinal wave and also the transverse wave. In the longitudinal wave you can observe the direction of the direction of the movement of the particles and the direction of the wave, the direction of the particles movement and the direction of energy transfer is parallel in the case of longitudinal wave, whereas the direction of the particle movement and the direction of energy transfer are in perpendicular directions. Here you can see very clearly the difference between the longitudinal wave and the transverse wave. Okay. Here one more example also, just I am showing you transverse wave and also the longitudinal wave here. So sound is produced, we can summarize what we learnt. Already we discussed three concepts: how the sound is going to be produced and the propagation of sound, and also the sound, for the propagation of sound requires medium, and also the sound is a longitudinal wave, and also the sound is a mechanical wave. Why sound is a mechanical wave? Why sound is a Longitudinal wave already we discussed. Just let us summarize. Sound is produced due to the vibration of different objects. Sound travels as longitudinal wave through a material medium. Sound travels as successive compressions and rarefactions in the medium. In sound propagation, it is the energy of sound that travels and not the particles of the medium. The change in density from one maximum value to the minimum value and again maximum value takes one complete oscillation, that is one vibration, one oscillation. The distance between two successive compressions or two successive rarefactions is called the wavelength. This is the thing what we learnt in this class. Now I will ask you some questions. Sound is produced by still objects or vibrating objects or moving objects or chemical reactions. Yes, that is vibrating objects. Which type of wave is sound? Transverse, longitudinal or electromagnetic or stationary? Yes, longitudinal wave. The speed of sound is maximum in air, water, vacuum, steel. Answer is steel. Why? Because steel is a solid. Because here the propagation of sound is going to be, because the particles has to push the surrounding medium particles, the surrounding particles of the vibrating object has to push the particles, because in solids the particles are tightly packed up now. So, the distance between the particles is very less, they can push the particles very easily. So, the speed of sound is maximum in steel, that is solid. Here there is an assignment I am giving to you. What is sound? How it is produced? These are the textual questions, you have to answer those, and also describe with the help of a diagram how compressions and rarefactions are produced in any. Describe with the help of a diagram how compressions and rarefactions are produced in the air near a source of sound. And also just I had given the solution also. Just put whatever the important keywords, also underline this. Why is a sound wave is called a longitudinal wave? Already we discussed the direction of the particles of the medium vibrates parallel to the direction of the propagation. And also why are sound waves called mechanical waves? Because the medium is needed, that's what. Suppose here you have to observe one thing. Already what we learned, sound requires medium. In the vacuum it can't travel. They asked that the same thing, they asked like this, suppose you and your friend are on the moon, will you be able to hear any sound produced by your friend? Suppose you and your friend are on the moon, will you be able to hear any sound produced by your friend? Because there must be a medium there. If no medium is there, you can't listen that one. So here up to this the lesson, the transaction of the lesson was completed. Now I am going to give a brief picture regarding what are the steps I followed during this lesson, what are the strategies, suggestive tips and suggestive steps and suggestive strategies what I followed during this demo lesson. In the 9th class sound lesson, according to the working days or some sort of things, just I kept as 10 periods, 10 actually I had taken here production of sound, propagation of sound and sound waves or longitudinal waves. These three things I had taken in a single period. Before teaching, here you have to adopt 3 steps. Before teaching, what you have to do? While teaching, what you have to do? After teaching, what you have to do? Before teaching, first of all you have to confine the learning outcomes, what you have to achieve, and the prior concept skills, prerequisites, pre-knowledge what the students has to get, everything you have to know, and the teacher references or resources, what else it is there in the teacher handbook or in your any reference books, you have to gather those, and also the TLM required, you have to gather that one also. And this is the while teaching, first of all you have to perform the hook activity that must catch the attention of the children towards the lesson. they have to pay the interest, utmost interest towards the lesson. Then according to the hook and readiness activity, interesting activity, you have to gather the experiences and reflections. There I kept the hook activity as the chirping of recognition of the some sort of sounds like chirping of birds, and also bell ringing and car moving, just the car is going to start, something like that. Because to create the interest, I kept the hook activity. After that, I summarized the experiences and reflections, everything regarding those. Based on that, I prepared some thought-provoking questions leading to the concept. First of all, every teacher has to pose these thought-provoking questions, then the students will definitely aspire to know the answers of those questions. Definitely they will grab the information what the teacher will tell. After that, some brainstorming session, sound, energy, some sort of things, because what they know in the real life scenarios regarding that particular subject and acquiring that, they will regain the pre-knowledge and everything what they learned in the previous classes. After that, you have to introduce the concept. After the introduction of the concept, we have to pose the mind map. After that, we have to make the students to underline the keywords, and they have to know what are the terminology, what are the keywords, how we are going to apply in the lesson. And after that, we are going for teaching learning process, the important aspect of the teaching the learning transaction. Here, 3 more type of activities we are seeing: I do, we do, you do. As the starting step of teaching learning strategy, first of all, explicit teaching, teacher modeling, I do. Here we had, after that you have to go for the CFU, open-ended questions, check for understanding questions. After that, group work, we do, and this is the suggestive timestamp according to your availability and that circumstances you can follow. And after that, summarization, closing. After that, evaluation and assessment or project or anything else. After that, you have to give the homework. After teaching, what you have to do? Selection of the concept to reteach based on the student responses and engagement. What are the concepts that will be difficult for your student? Which concepts has to be reteach? You have to reteach some particular concepts, you have to decide. And also the selection of some sort of challenges will be there in your classroom teaching, and the equity according to the NEP policy to promote the experiential learning and to attain the equity, and also what the affordability, everything you have to selection of alternative suitable pedagogy and also strategies. Therefore, you have to select the alternate suitable pedagogy to overcome the challenges faced in the classroom teaching. What I had done in this lesson, just I am going to post. Just I confirmed the learning outcomes. Students will be able to explain the propagation of sound, identifies the reason for the production of sound, draw the structure of sound wave, express the need of medium for the propagation of sound wave. All these learning outcomes what we keep here, that must be achieved by the students at the end of the lesson. Please take care about these learning outcomes, because they will reflect as the questions in the coming assessments. After that, the second one, prior concept skills. How do flute and whistles produce sound? How the sound is going to be produced? What is the most important part of the human body that is useful for the production of sound? Resources I kept for some simulation links also. As a TLM, I use the tuning fork, balloon, rubber band, paper cups, thread, scissors, thread and simple pendulum, glass, steel plate, spoon, everything you have to make sure that, ensure that all the TLM, better to actually select the low cost, no cost resources. Here in the case of teaching learning transaction as a hook activity, I perform the identification of sounds. After that, as a part of experience and reflection, I had given a project work, make a list of sounds you hear in your surroundings. After that, I posed some thought-provoking questions leading to the concept how sound can be produced, how we are able to hear the sound, does sound requires a medium to travel, something like that. After that, I introduce the concept, I post the mind map, I make the students to underline the keywords, and as a part of teaching learning process, the teacher modeling I performed the activity 11.1, 11.2 with the tuning forks, and I used the simulations. And also we do activities, that is the group activities. As a part of group activities, make a list of different types of musical instruments and discuss with your friends which part of the instrument vibrates to produce a sound, and also paper cup phone preparation. Students used to check the sound propagation in solids and liquids, gases. Likewise, I had done some sort of activities. And as a part of independent work, stretching and vibrating rubber band, formation of waves with the slinky. Likewise, I kept some sort of activities. After that, I summarized, and also I had given some evaluation and also the assignment. So these are the things what I covered here. Just I am requesting you, all the teachers, first of all, ignite the knowledge. First, ignite the children towards the readiness towards the science, and then adopt the skill of questioning, observation. Those are most important. ప్రశ్నించు 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 ప్రశ్నతోనే జ్ఞానం ఆర్జించు. అజ్ఞానిగా నువ్వు ప్రశ్నించినప్పుడే విజ్ఞానిగా నువ్వు అవతరించదువు. ప్రశ్నించు ఆ క్షణమే అజ్ఞానము, ప్రశ్నించు ఆ క్షణమే అజ్ఞానము తేటపరుచుకున్నాక మరి విజ్ఞానము. ప్రశ్నించు ప్రశ్నించు. సో ద క్వశ్చనింగ్ ఈజ్ ద మోటివేషన్, igniting and questioning. First of all, where it was happened, how it was happened. Likewise, you have to inculcate the habituation of questioning among the students in all sort of activities. I do, you do, we do, everything that must be lead to the beautification of science, enrichment of science, and budding of scientists in the current generation. And also I am requesting you one more thing. Please use the app, because ఇక్కడ నేను మీ స్కూల్స్లో చాలా వరకు ఎక్విప్మెంట్ లేదు, లేకపోతే వాడడానికి కుదరటం లేదు, ల్యాబ్కు వెళ్ళడం లేదు. ఇలాంటి విషయాలను పక్కన పెట్టి ప్రతిదానికి ఒక మార్గం ఉంటుంది. కాబట్టి మీరు ప్రతి దానికి కూడా చిన్న చిన్న యాక్టివిటీస్, ఏదో పెద్ద పెద్ద యాక్టివిటీస్ చేయాలని కోరుకోవట్లేదు. జస్ట్ దిస్ ఈస్ ఎ స్లింకీ. We can demonstrate as a, here you can demonstrate as a longitudinal wave, we can demonstrate as a transverse wave, and also in the bell jar experiment we can use micro equipment also. Just likewise, and పిల్లలందరితో చిన్న చిన్న ఎక్విప్మెంట్, ఒక చిన్న వాక్యూమ్ క్లీనర్ చేయించండి. ఇలా అలాగే మన ప్రొడక్షన్ ఆఫ్ సౌండ్ త్రూ ఏ స్ట్రా ఆల్సో వీ కెన్ teach the production of sound, and different types of sound. By cutting the length of the straw, we can demonstrate so many activities we can demonstrate. So మీ అందరితో కూడా ఉపాధ్యాయులందరినీ మీ అందరినీ కోరుకునేది, పిల్లల్లో ఆలోచన శక్తిని, సైంటిఫిక్ టెంపర్మెంట్ని మీరందరూ కూడా కలిగించే విధంగా, రేకెత్తించే విధంగా మీరందరూ కృషి చేస్తారని, టీచర్ రిసోర్సెస్ అన్నిటినీ బాగా యూటిలైజ్ చేసుకొని అందుబాటులో ఉన్న అన్ని రిసోర్సెస్ని ఉపయోగించుకొని ఈ విధంగా ప్రతి టీచర్ కూడా ఒక చిన్న టీచర్ సైన్స్ కిట్ కూడా డిజైన్ చేసుకుంటారని మైక్రో లెవెల్లో కోరుకుంటూ, థ్యాంక్ యూ.